In this tutorial for the math proficiency test for EQAO for new teachers in Ontario, we're going to take a look at proportional reasoning with some probability and data concepts. That's the last one of the later topics here. This is actually data as well, or there's a little bit of probability and data as well. I've highlighted in red the ones we're going to talk about here. There's another tutorial on the linear, nonlinear relationships and equations. You can check that one as well. So this is about ordering, comparing whole numbers, integers, decimals, and fractions, working with fractions, decimals, and percent, ratios, proportions, rates, and unit rates, solving problems involving both proportional reasoning and some probability. So that's what we're going to focus on in this through a number of examples. A few of them I've made up as multiple choice questions, but a lot aren't because this is more an instructional video than just examples. So in the description, you can find links to some practice exercises for this. Most of the practice exercises are set up as multiple choice questions. And then there's another answer document as well, so check that out as well. Please feel free to leave comments about the video. If you have questions about any of the answers or questions, please let me know via a comment. I'm really not sure how much traffic I'll get for this, so I'll do my best to assist people as much as I can, unless it really inundates me. So I'll do my best. So without further ado, let's get into the first example. So this one, you're asked to order the following fractions from least to greatest, and I'll mention that after these 4 instructional videos, I also have 4 tutorial videos that go over the answers to the actual EQAO practice exam, not the real exam, the practice one. So you can check that out as well. I'm going to put links to all that in these videos as well in the description. So order the following fractions from least to greatest. So we've got these 5 fractions, and I know in the practice, the EQAO practice, they have one of these questions where, like, I think it's all the numerators are the same. So I have a few here that the numerators are the same. There's a few that the denominators are the same. Okay, so I'm going to talk about those ideas. So first of all, if I compare 3/4 and 3/8, 3/4 is bigger than 3/8. Notice the numerators for those two are the same. If you make the denominator larger, there's more parts in a whole, so then that would have to be smaller. Just to show you, if I have a circle, and so notice I've divided this one into 8ths and this one into quarters. So 3/4 would be this much. That's 3 of 4 pieces. So this one here, there's 8 parts, so 3 of 8 parts. You can see that it is a smaller amount, a smaller piece of the pie or of a whole. So that's why 3/4 is greater than 3/8, or 3/8 is smaller than 3/4. Now, let's talk about 2 that have the same denominator, the 5/2 and the 7/2. So I meant the 5/2 and the 5/8. They had the same numerator. Okay, I will talk about these next in a moment here. So they have the same numerator, and if they have the same numerator, again, the bigger denominator, there's more parts. So this would have to be larger. See, 5/2 is more than a whole. That's actually 2 1/2. This isn't even 1. 5/8 is actually just a little bit over 1/2. So actually, see, this is 3/8 is shaded here. 5/8 would be this much here because that's 5 of 8 pieces, the non-shaded part. So when you have 2 fractions with the same numerator, the one that has the smaller denominator is bigger. Okay, so now here are the 5/2 and 7/2. So notice denominator is the same. Okay, 5/2 would be smaller than 7/2 because if my denominators are the same, see, 5/2 would have to be smaller than 7/2 for the same reason that 5 is smaller than 7. Okay, so denominators are the same, so the larger numerator is going to be the bigger amount. So I just wanted to mention that because if the numerators are the same or the denominators are the same, there are some relationships you can see without like converting them to decimals. I can see this kind of question would be in the part where you don't have a calculator. Okay, so if you want to compare them all, the best way to do that, like all five of them, this is just comparing two at a time, is to get a common denominator. Okay, like these two have a common denominator. Okay, so if you look at, 4, 2, and 8 are the denominators. If you list the multiples of 2, 4, and 8, so I'm going to do that right over here. So here's the first several multiples of 2, 2, 4, 6, 8, 10. Now let's do 4. Okay, the first several multiples of 4 are 4, 8, 12, 16, etc. And then 8, if we go 8, 8, 16, 24, etc. Now notice that 8 is the first number that is in all of the lists. So the least common denominator would be 8. There are other common denominators, larger ones. Okay, so for example, 16 is in both lists. You can see it here, here, and see if we went 10, 12, 14, 16. 16 is a little further along here. That is another common denominator, but the smallest one is the one we normally would use. Okay, so what I'm going to do is I'm going to take each of these fractions and see, I want to put them all over 8 so I can compare them. So what do I multiply the denominator of 4 by to get 8? Well, it's 2, so multiply by 2. So that's going to be 6 over 8. Now let's do the 5 halves. I would multiply the denominator by 4 here to make it 8. So that's going to be 28. Now let's do the 3/8 is it already has an 8 in the bottom, so I'm gonna skip to the 7 halves. So 7 halves, I would multiply it by 4 just like I multiply this one. So you see that's going to be 28 eighths. And of course I've already got the 3/8 and the 5/8 done. So I'm comparing these now. So if you look 6/8, 28, 28/8, 3/8, and 5/8, see 3/8 should be the smaller of all the numbers. So least to greatest, we would write 3/8 first. You see 5/8 is the next biggest one. 6/8 is going to be a little bit bigger. So 5/8 would be the next one. And 6/8 would be next. Now, originally, instead of 6/8, we called that 3/4. So I'm going to see you're actually writing these ones. So I'll write 3/4 instead of 6/8 because that's what the question asked. And then, okay, we're down to these two. Well, 28 must be smaller than 28/8 because 20 is less than 28. So 28 is 5 halves. And then the last one would be the 7 halves. So that's how you would list them all in order from smallest to biggest. Now, if you had a calculator, you could actually just change them all to decimals. So, for example, let's say we had our calculator here. Lower enough so you can see. So I could just start going 3 divided by 4. C is 0.75. And I could, now, on a piece of paper, write 0.75 down. And next is 5 halves. See, 5 divided by 2 is 2.5. So I could actually change them all. If you're in the calculator part, you could just change them all to decimals and compare them that way instead of doing the common denominator. Actually, let me take a moment to do that. So actually I'll write them below. So 0.75 was the first one, comma, and the 5 halves was 2.5. So let's get our calculator again here. So the next one is the 3/8 divided by 8 is 0.375. So this is 0.375, comma, and then always clear before you do something else in the calculator. 7 divided by 2 is 3.5, so that's the next one, 3.5. And 5/8, if you clear 5 divided by 8 is 0.625, so 0.625. Okay, so if you compare these, see 0.375 is the smallest one, so that's why we would put 3/8 first. And then next after that is the 0.65 is the next biggest decimal. See, the 0.75 is a little larger. So the 0.625 would be the 5/8. Okay, so we've done this one and this one. 0.75 is the next biggest, so the 3/4. See, that goes next. The only two we have left are 2.5 and 2.5 and 3.5. So 5/2 goes next, and the 7/2 would be the biggest. So that's how you could compare them using a calculator if you had if you're in the calculator part of the proficiency test. Okay, let's go on to the next example. Example 2, which of the following has the lowest cost per kilogram? So here's one. It is written as a multiple choice question. So what we would do when it says cost per kilogram, that's telling you to take the dollar amount. Per means to divide by the number of kilograms. Okay, so that's what that's telling you. So I would take for this one the 323.25. I didn't bother to write the dollars and the kilograms and divide them. And so that works out to 227, which would be $2.27 per kilogram. See, this is dollars, this is kilograms. That's why the units are dollars per kilogram. So this one, $5.99 divided by 3.05 is $1.96 per kilogram, and we do the same for all of them. Oh, now this one here, notice these are all in kilograms. This is 600 grams. So you would have to convert. See, there is 1,000 grams in a kilogram. So that's 600 grams. You take 600 and divide it by 1,000. So that's how I know that it's 0.6 kilograms. You don't want to divide it by 600 because then you would have cost per gram, and it's harder to compare that to cost per kilogram. And then the last one is the same as the first two. $9.99 divided by 5.02 works out to $1.99 per kilogram. So obviously this one is a little bit cheaper than this one, so that has the lowest cost per kilogram. Example 3, a grocery store sells a package of 8 oranges for $3.99. What is the cost per orange? So again, cost per orange, we would divide the cost by the number of oranges. So we go $3.99 divided by 8, which works out to, it's actually not exactly 50 cents because it's not $4. $3.99 divided by 8. Okay. So 0.49875. Now, if it's money, you normally round money to 2 decimal places. So we want to round to this place here. That 8 makes the 9 round up to a 10. So that's why this would round to 50 cents, because you would carry that 1 up here and it would be 0.50. So 50 cents or half a dollar per orange. Example number 4, you need to raise the end of a lawn tractor up, and you only have wooden blocks that are 1.5 inches thick. So the question is, how many blocks do you need to raise the end of the lawn tractor more than 6 inches? Now, 1.5 is the same as 1.5 inches. So to figure out how many, I want to raise it up more than 6 inches. So if you divide 6 by 1.5, that's exactly 4. But see, that would raise it up, if you did 4 blocks, it would raise it up exactly 6 inches. It says more than 6 inches. So 4 blocks only gets you 6 inches, but you want to be more than that. So you would need an extra block. So you'd want to use 5 blocks, or of course more. Okay. So this would be 5 blocks. Example 5, a sweater retails for $89.99. So it goes on sale for 20% off, and a week later, and stores often do this since it hasn't sold, it's reduced by another 30%. So the question, what's the new price with both discounts? So I'm going to show you a pretty normal way to do this, and I'm going to show you another way. Again, if you have access to a calculator, you can do this, which is quicker than the normal method. So you take $89.99 and you find 20% of it. So 20% is the decimal of 0.20. Remember, percent means out of 100. So if you divide that by 100, that's how you get the 0.2. Now 0.2, 0.20 is the same thing. And then I'm going to take 89.99 times 0.2. Okay. So that's $17.99.8. So again, money, we want to round to this decimal place. So the 8 makes that 9 round up to a 10, which makes that 9 round up to a 10. So that would actually round to $18 even. That would be the discount. So to get the new price, we would take what it was originally sold for, and we subtract the discount, which is $71.99. So that's the 20% off. So now we're going to take another 30% off because it didn't sell. So we would take the $71.99 and multiply it by, now 30% as a decimal would be 0.30. So we multiply that and we get 2160. So 2160 is going to come off the 71.99. So the new price, or the final price, before any taxes, we're not talking about taxes in this question, would be 71.99 minus that 2160 minus the final discount. So its final price after both discounts is $50.39. Now, question B asks, and I'm going to talk about a common misconception in B here. It says, by what percentage with both discounts has been reduced? And a lot of people look at this and say, well, it's 20% off and it's 30% off, so we would add them and it's going to be 50% off, okay? Because 20 and 30 get to 50. But that's not correct. So in B here, if you look at what the total discount is, we took $18 off and then another $21.60. Okay, so if you add those together, all together it's been discounted by $39.60. So to get the percent that's been discounted, okay, the percentage discount, you divide how much is discounted by, see that's the discount, by the original price. And of course, to change it to a percent, we multiply that, whatever decimal it is, by 100. And if you do that, okay, so it's 39.60 divided by 89.99, so 39.60 divided by 89.99, okay, 0.40, did I not derive it? Okay, 39, I think I punched that for, I think I did 36.90. So 39.60 divided by 89.99, there we go. Okay, so 0.4400. So that's, and when you multiply that by 100 then, okay, it's actually discounted 44%, like a slight amount, but to the nearest percentage would be 44%. And the reason it's not 20 and 30 is because, you see, if you've taken the 20% off, you're at $71.99. When you calculate the next 30% off, it's not off the original amount, it's off the new sale price. So 30, if you were taking 30% of $89.99, then see, this would be bigger and it would actually be discounted more. Okay? So it's because there's a compound, like the second percent isn't off the original amount, it's off the sort of intermediate amount. Okay? Example number 6, which of the following percentages is closest to 7/16? So what you're going to do to change, so we're really changing a fraction to a decimal and then a percent. So you would take $7 and, oh, I forgot my 44% here. If you divide 7 by 16, you get 0.4375. And then in order to change that to a percentage, we multiply it by 100. So that's 43.75. And a lot of these EQAO questions are phrased, what answer is closest to? See, these are always to the whole percent. See, 44% is closest to 43.75. So we would circle or indicate that 44% is the correct amount. Question number 7, a union negotiates a new collective agreement for its members. In the first year, they get a 3% raise. In the second year, they get a 5% raise. So the question is, by what percentage has their wage increased over the 2 years? Okay. And this is another multiple choice question. So, you know, and actually, so you might guess from the last one, see, if we had 3% and 5%, that's 8%, that this actually, same as the discount here, discount question, that should not be the correct answer. Because the 5% isn't on the original amount you're making, it's on some raised amount, the amount that's raised by 3%. So one way we can do to figure this out is, and actually I'm going to back up a moment. I remember something I had said I was going to do on this page, for example 5, I'd forgotten, so I'm going to go back there for a second. I mentioned I was going to show you a shorter way to do this. So let's bring the calculator back here. So if we start at the 89.99. Now, first you're taking a 20% off. Now, if you're taking 20% off, you're still paying 80% of the original amount. Okay, so we always talk about discounts, but see the 71.99 is actually 80% of this. Because you see, if I take my 89.99 and multiply it by 0.8, okay, there's the 71.99. Okay, now, and then you're taking 30% off. Now, if you're taking 30% off, you're still paying 70%. So I'm subtracting from 100. 100 minus 30 is 70. So we take this 71.99 and multiply it by 0.7. Okay, there's the 50.39. And in fact, what you can do is just go 89.99 times 0.8 times 0.7. Okay, and there's a quicker way to get 50.39. Okay, so and actually, even the discounted 44%. Okay, see if you take 0.8 times 0.7. Okay, see, so the final price, that means the final price is 56% of the original. So 100 minus 56 is that discounted 44. Okay, so that's another way to actually do example 5. Okay, let's go back to example 7 here. So now, so the union members, they get a 3% raise in the first year. That means that their new wage is 103%, 3 added on to 100, of the previous one. And 103% as a decimal is 1.03. See, if we take, clear, 103 and divide it by 100, okay, there's the 1.03 to convert it to a decimal. Now, in the second year, they get a 5% raise, so that means their new wage is 105% of their previous one, which as a decimal is 1.05. Now, if we multiply the two of these together, 1.03 times 1.05, you get this, 1.0815. And so that means, so their wage after the second year increase is 108.15% of what they were getting before this contract. Okay, so that means that, so that's 108.15%. So that means that their wages have increased by 8.15% over 2 years. Okay, so it's a little more than 8% because this 5% is already on a larger amount that's been increased by 3%. And you might say, well, that's not very much. 8.15% isn't much more than 8%. But if you think of it, let's say you had a career of 30 or 35 years, and you got a little bit more percent every year, that makes a really big deal after 20 or 30 years. Okay, it's a lot more. As a teacher, that means also that your pension is higher, okay, because of that compounding amount to the interest. So 8.15% is the correct answer for number 7. On to number 8. Salim and Tariq both work jobs where they earn an hourly wage with no base pay. Salim earns $3.51 in 15 hours, and Tariq earns $3.30 in 12 hours. So which of the following is true? So in order to answer these, it's going to be a lot easier to figure out how much each person is making per hour. So for Salim, we divide 351 by 15, so he's making $23.40 per hour, and Tariq 330 by 12, so he's making $27.50 per hour. So we're going to use these. Now, A says Tariq earns $5 an hour more than Salim. Well, he is getting more, but if we subtract them, he's only getting $4.10 an hour more. He's not getting $5 an hour more. Okay, so A is not true. B says Salim is earning $1.75 an hour more than Tariq. Well, that's not true. Salim's actually making less per hour. Okay, so B cannot be true. In 10 hours, well, in 10 hours, we need to figure out how much each of them makes in 10 hours. We take Salim's wage and multiply by 10. So that's $234. And Tariq, we multiply his $27.50 an hour by 10. So he's making $275. So that C is saying in 10 hours, Tariq earns $41 more than Salim. Yeah, he does make more. And if we subtract them, we do get $41. So C is the correct answer. And just to show you that D is not correct, Okay, there's only one correct answer. If they each work 40 hours, let's figure out how much they each make in 40 hours. So Salim, this would be Salim's and Tariq's, and if we subtract them, you get 164. Now, pay careful attention to the wording here. If they work 40 hours, Salim earns $160 more than Tariq. Well, it's actually the other way around because Tariq's the one making more. Okay, so he's the one that earns $164 more than Salim, not the other way around. Question number 9. So this is getting into a little bit of the data concepts. So what fraction of the diagram, this is more about actually fractions, I suppose, than data. Well, what fraction of the diagram is not shaded? So not shaded, we want to count how many of the squares are not shaded. So I'm just going to count them here. And so that one's 5, 6, 7. This would be 8 here. 9, 10, 11, 12, 13, 4. So there's 14 not shaded. Now it's a 4 block by 5 block rectangle. So there's 20 rectangles altogether, all the same size, of course. So the fraction that's not shaded would be our 14 out of 20. And if you divide both of those by 2, they're both even, it reduces to 7 over 10. So 7/10 is not shaded. If you're asked what the shaded part is, it would be 3/10. It would be shaded because it would be 1, 2, 3, 4, 5, 6. This would be 6 instead of 20, which would be 3/10 if you've reduced it. So here's some data, mean, median, and mode question. Example 10, 10 100-meter race times are given all in seconds. And so this is the data points. And in case you don't remember, median is the middle data point or average of the two middle data points, if there's an even number of numbers, when the data is ordered. You have to put in order. Median is the only one that has to do with ordering the data. Mode is just the most frequently occurring data point or points. And mean is the sum of all the data points divided by how many of them there are. So the first thing for median you want to do is put them in order. So 9.5 is the smallest, 9.9 is next, then there's two 10.6s, etc. And so that's all the data points. The 13.1 is the highest time. So now there's 10 points, so there's not a middle one, there's two middle ones. Okay, whenever there's an even number of data points, there's 10 of them, there's going to be two middle ones. So notice those are the two middle ones because there's 4 below and 4 above. Okay, so in order to get and to get which ones those are, if there happen to be a large number of data points, see if we take 10, there's 10 data points divided by 2, that's 5. So the 5th and 6th ones, which are these ones, see 1, 2, 3, 4, 5, 6. So the 5th and 6th are the two middle ones. Okay. So in order to find the median, we would average these two middle points. So we take 10.8 and 11.3 and add them and divide that by 2. 10.8 and 11.3 add to 22.1, divided by 2, which works out to 11.05, or about 11.1. So that's the median. Now the modes. Notice there's two 10.6s. There's only one of each of these. There's only one 11.7, but see there's two 12.5s, and there's only one 13.1, and one of each of these. So there's two numbers that there are two of each. So there's two modes. They're both 10.6 and 12.5. This is said to be bimodal data. Bi, like bicycle, has two wheels. If there were 3 modes, we'd call it trimodal data. Now, for the mean, we want to find the sum of all the data points. Okay, so we add them all up, and they add up to 112.5. So we go 112.5 divided by, and there's 10 numbers. Okay, we're told there's 10 of them. You could count that there's 10 of them. Okay, so that works out to be 11.25. That would be the mean. So there's the mean, median, and the modes. Question B asks, if another time of 12.5 seconds is added, how does that change each statistic? Okay, so let's recalculate. So for B, here's all the data points, and we've got this new 12.5, another 12.5 times. So that's the new one. Now, the median, because there's an odd number, now there's 11 numbers. See, 11 divided by 2 is 5.5. So what you do to get which one it is, if there's an odd number, then increase that by 1 and divide it by 2, and the sixth one is the middle one. See, that's the sixth one. So for example, 1, 2, 3, 4, 5. There's 5 below it. 1, 2, 3, 4. There's 5 above it. Okay. So let me get rid of my writing here. Just erase all this. Okay. So the median is 11.3. Okay. So the median is a little bit higher because we stuck in an extra higher point. The mode. Well, you see now there's 3 12.5s. There's only one of everything else, except we do have the two 10.6s. But see, the mode is the most frequently occurring data point. There's only one mode now. Okay, there's no 10.6 included for the mode anymore because there's only two of those, but there's three of the 12.5s. So the mode's the higher number. Now the mean, you could go and re-add all of them up again, but if you know that all the brown ones here add to 112.5, you could just take that previous sum and add the new 12.5 and then divide by 11 because there's 11 numbers. So if you add those together, that's 125 divided by 11, which is 11.4. So notice again, we put in a bigger number, so the mean is going to be a little bit larger. Okay, so that's how it changed it. Example number 11 here. A group of students' heights are given in the table. So we have all these people, but we don't know Quincy's. It says that the mean of all the student heights is 171.4. How tall is Quincy? So we're asked to find this if that's the mean. Now, if we add up all the other numbers, these ones here and the 166, that adds up to 1,019.5. So remember, this is the formula for the mean. It's the sum of all the numbers divided by n is often used in formulas and data for the number of data points. So that's what n represents, how many there are. Now, if we fill in what we know, see 171.4 is supposed to be the mean. Now, the sum would be this plus, I'm going to call Q Quincy. Quincy is Q. Divided by, and there's 1, 2, 3, 4, 5, 6, 7 people here. So we put a 7 here. Now we're trying to isolate for Q, so we're going to use a little bit of algebra here. All this is divided by 7 right now, so the opposite of dividing by 7, so we can isolate this expression in the numerator, is the opposite of dividing by 7 is to multiply by 7. And the reason for that is so that these 7s divide out. Now on the left here, if we take, whoops, I did not mean to do that. If we take 171.4 times 7, okay, so that's 1199.8 on the left, would equal this numerator expression. Now, I'm trying to isolate for Q. So this 1019.5 is added to the Q, so the opposite of adding 1019.5 would be to subtract 1019.5. So this subtracts to 0, leaving me that Q is 1199.8 minus the 1019.5. So Quincy's height should be 180.3. So that's how tall Quincy is. Now B, it says how tall would an 8th student, another student, have to be to increase the mean height by 3 centimeters? So again, so that's how tall Quincy is. So again, the mean is the sum of the numbers divided by n. Now, the previous mean was 171.4. So if we add 3 to that, then that would be 174.4. Now the sum is the sum of all these guys. Okay, these all would add to 1019.5. You could go 1019.5 plus the 180.3, but that would be the 1199.8. Okay, plus, and X represents our new 8th student. And now there were 1, 2, 3, 4, 5, 6, 7. So that means that there's now going to be 8 people. So that's why n would be 8 now. Now to solve for that, very same idea way we solved for q here a moment ago. So this expression we want to isolate for that. It's divided by 8. So I would do the opposite of divided by 8. So I multiply by 8. 8 times 174.4 is 1395.2 would equal this numerator expression. And for the same reason, see, I subtracted the 1019.5 from both sides. So I'm going to subtract this 199.8 from both sides. So that subtracts to 0. X would just equal this subtraction, which is 195.4. So that's how tall this newest extra student would be. He has to be quite tall to increase the average by 3 centimeters. Okay, one last question here, one last example, a little bit of probability. We're told that a container has 4 red, 5 blue, 6 yellow, and 9 green marbles. And it says determine each probability. Now, I didn't write it in the question here, but the assumption is that the person that's picking them out randomly can't see them. Okay, so he or she randomly reaches in and grabs a marble. So what's the chance a randomly selected marble is blue? Chance, probability, same thing. Okay. So we want to know how many marbles are all together. So we would add 4, 5, 6, and 9, and that's 24. So it's 24 marbles in the container. So the probability of a blue one, now notice that there's 5 that are blue. So they're probably getting a blue one is 5 out of the total, out of 24. So that's the chance of getting a blue one. B asks, what is the probability a randomly selected marble is not red? Now, there are 4 red ones, so how many aren't red? Okay, so what we would do is take the total and subtract. There's 4 red ones, so there's 20 that aren't red. Of course, you could add 5 and 6 is 11 plus 9 is 20. You could do that too to get the 20. So the problem is not red would be that 20 out of 24. So that's the probability it's not red. Now we can reduce that. So the multiple choice answers wouldn't leave it as 20 over 24. They would reduce them. Notice that 4 goes into both of these. 4 goes into 25 times, and 4 goes into 24 6 times. So that reduces to 5 chances in 6, or 5 6. And that's the end of the tutorial. Again, please feel free to leave comments. If you have questions about the practice exercise, remember in the description for the video, there will be links to both some practice exercises. Lots are written as multiple choice, but not all. And there's a solutions document there too. And please check out my 4 tutorials on the actual EQAO practice test too. That explains all the solutions, including the pedagogy answers as well.